Hello everyone, welcome on this e-learning platform. Here are the informations about the instructor in the course. In this video we will be seeing the proof of some equations of motion. First two equations of motion have been proved in the previous video. In this, the rest of the two will be proved. Well, this third equation of motion, which is v square minus u square is equal to 2as, is basically the combination of the first two equations, in which the first equation was v is equal to u plus at, and the second equation that we have proved earlier is s is equal to this. S is the displacement, which is equal to ut plus half at square. Now if we combine these two equations together and eliminate the time, we will find the third equation will be proved. So let's do that. From the first equation, if we borrow the t value, you will find this t value will turn up as v minus u divided by a. And if we substitute this t in the second equation, then you will find the displacement s will be equal to u into t, and that t can be substituted by the number or expression that we have just found. So this is going to be in place of t we can write v minus u divided by a plus half into a into the same number square. So we need to make the square of this number. So let's make that number and squaring it. V minus u divided by a and squaring this thing. This will be solved as follows. If we go for simplification, we can take 1 upon twice a as a common, and since we have taken two downsides, so multiply two upsides, so this will become twice u into v, the first term, minus twice u square. And if we take this thing from the another segment of the expression, you will find it's going to be a square. A will settle out, so ultimately it will lead to v square plus u square minus twice uv. Once we have settled with this, you will find this s is going to be equal to, inside in this bracket you will find u square, and u square will settle down. 2u will get cancelled out, so finally it will become v square minus u square divided by twice a, which further can be rewritten as v square minus u square is equal to twice as, and that was something we are supposed to prove as a we know as an equation of motion, or rather third equation of motion. This fourth equation is about s nth, the displacement during nth second, that means between n minus 1 to n second. Now to get this thing, we need to find first AC value, the displacement from A to C. So if we need to find the displacement from A to C, so this AC will be equal to u into t, place we replace by n, plus half a into t square, which is n square. Now if we write AB, the distance AB or displacement AB, this is going to be for n minus 1 second, so in place of t we'll write n minus 1. So expression will turn off like this. Now to find the displacement during nth second, which is BC separation, this is going to be equal to AC minus AB. If we subtract these two equations, you'll find it's going to be equal to u inside a bracket n minus n plus 1 plus half a n square minus n minus 1 square. If we simplify this, so this becomes s nth, this is going to be equal to u plus a by 2 in bracket 2